Okay, I really like this question because it allows us to really understand why we use coefficients of variation in a percent form and not just rely on our mean or our standard deviation. And that's really important to understand because most of the general population understands information in percents. So something like 50% off shoes, or even a 40% increase in our energy bills. Thank you, Enron, this winter. Really appreciate that. And I like it because it really we can understand how variation, or more specifically to that, variability, plays a role in predicting future behavior or future actions that we want to see depending on what the question is asking. So in this question, this is question 5 from the review. It says center records show the following statistics on temperature for a sample of days during the winter and a sample of days during the summer months. So our mean or average for the summer is 26.6 degrees, and our average temperature in the winter is 13.7 degrees. Hopefully that is not a surprise. Winter should be colder. And the standard deviation for summer is plus and minus 4.67 degrees. And for our standard deviation for our winter, it's plus and minus 3.86 degrees. Now, what would be really interesting here is if, given these numbers, it's on average in the summer we have 26.6 degrees. It can go up to above 30 degrees, or it can go down to be about 21, 22 degrees, and that's just simply taking into account that standard deviation, adding 4.67 to the 26.6 or subtracting it to get that first standard deviation, or our range essentially. Now, we could argue, and similarly we see this with our standard deviation for the winter. Now, we see a smaller standard deviation for the winter, which we might be inclined to think that this data is more predictable, that the winter is more of a reliable temperature measurement. But that might not necessarily be the case, and this is where coefficient of variation comes in back to that percent. So we're going to actually calculate using standard deviation and the average to determine what has the better variability for us. So our coefficient of variation formula, which is provided on the test, but still, we should be understanding these formulas, is we take our standard deviation, which is represented by the letter S, and we're going to divide that by the average, which is represented by the X with the line over it. And we're going to multiply that by 100%. So while we're doing this question let's start with summer. It really doesn't matter because the question is basically asking us, based on the coefficient of variation, which season has more variation in temperature. So based on standard deviation right now, I'm going to say the summer has more variation in it, but we're going to see if that's actually accurate based on that variation, which really tells us how reliable the data is for future predictions. So for the CV for summer, let's say, I'm going to take my standard deviation, so the 4.67, and I'm going to divide that by the mean, which was 26.6, and multiply that by 100%. So if I take 4.67, I divide that by 26.6, I end up with decimal 1755639.1. Then I multiply that by 100%, and sticking to 2 decimal places as we've been doing for the test, I end up with a variation of 17.56%. So that's the variation for summer. So now we're going to do the variation for winter. So the mean for winter, just because I've erased the information, is 13.7, and our standard deviation is 3.86. So for our CV, our coefficient of winter, I'm going to take my standard deviation, which is 3.86, and I'm going to divide that by the mean, which is 13.7, multiply that by 100%, so I get it in percent. So 3.86 divided by 13.7 gives me decimal 281751825. Multiplied by 100% gives me 28.18%. So our CV for summer, as up here, is 17.5% compared to our CV for winter, which was equal to 28.18%. So based on our coefficient of variance, the winter actually takes the cake in this one by almost 11% if we're actually comparing these numbers here. So because the CV for winter is higher, it has more variation to it. So where we can apply this in just your personal life is, let's say you want to book a vacation, and you want to know you've got like 3 destinations in mind. Well, before you plan and you want to make sure you can enjoy the sun and the beach or whatever you're doing, maybe look at look at their forecast trends. Go back to their history records, and very easily you could obtain the average and go and get the standard deviation through your own calculations to show what location is better. Ultimately, a location that has low variation in temperature is probably going to be there's going to be a better chance, a higher likelihood that weather you want will be there when you actually travel. So I hope this helps. If not, please let me know and I can provide a different explanation. Thank you.